This is Objective 10.2b. We're going to continue our study of solving trig equations, and these equations that we'll be solving today will be quadratic trig equations. So we'll be using our quadratic strategies to solve them. And what we'll do is we'll rely on our factoring skills to solve, and if we can't factor, then we'll go to our graphing calculator to solve. We'll also use our unit circle. So those are your objectives, is to put those three things together to solve trig equations. Some notes real quick. When we solve quadratic equations, we apply the principle of zero products. That says if the product of two numbers is zero, then at least one of the factors is zero. So like, for example, if I say a times b equals 0, then I know either a has to equal 0 or b has to equal 0, or they actually could both equal 0. And when we solve quadratics, like for example, say we have x squared minus 3x minus 4 equals 0, and we want to solve that equation, we would factor that. We're looking for the factors of -4 that add to -3. And that would be what? -4 and 1. So x minus 1, x plus 1, x minus 4 equals 0. And then we would set either this has to equal 0 or this has to be equal 0 by the principle of zero products. So x plus 1 equals 0. So either x is -1 or x minus 4 is 0 and x equals 4. So this is we're going to factor, that's what we're going to do. We'll set the equation equal to 0, and then we'll find the zeros. So here we have example 5 that says solve 2 cosine squared u equals 1 minus cosine u in the interval 0 degrees to 360 degrees. And so it's definitely a quadratic trig equation. Look at that quantity squared there. And there's a quantity to the first power, and there's your constant. So we could, if you would prefer, you could let cosine u be replaced with x if you want to, and then you could solve it quadratically like you would, if that's helpful for you. So we could just replace 2 cosine squared u with 2x squared equals 1 minus x. And then we just rearrange this to find the zeros. So we'll add x to the other side, subtract 1. So rearranging the equation, add x minus 1 equals 0, and then we would factor this out to find our zeros. So we're looking for the numbers that multiply, AC method, to -2 and add to 1. So I think 2 and -1 would satisfy that. So we'll break up our middle term here to factor that. So that'll be 2x minus 1x minus 1 equals 0, and then we'll factor by grouping here. You want your common factors in this front group. That's a common factor of 2x, leaving you with x plus 1. And then in the second group, they have a common factor of -1, so we'll factor out the -1, leaving us with x plus 1 equals 0. So we've got it factored here. Their common factor in the two groups was x plus 1. We factor that out. That leaves us with 2x minus 1 equals 0. So here's what we know. X plus 1 equals 0 using our principle of zero products, and 2x minus 1 equals 0. So x equals -1, or 2x equals 1, x equals 1/2. So I'm going to come up here to finish this workout. So here's what we know. Cosine of u, reinserting, we're going to let x return to cosine u here. So cosine u equals -1, or cosine u equals 1/2. And we're just going to go to our unit circle here, and we're going to find those values. Or you could use your exact value trig sheet. Okay, so cosine u is your x coordinate, and this is on the unit circle where cosine u equals -1. So that's 180 degrees. And then cosine u equals 1/2. That's when x is positive 1/2. So that would be here on your unit circle along this line where your x is 1/2. So we'll be talking about this angle here, which is 60 degrees. Or this angle here, as I'm going from 0 to 360 degrees, we'll subtract 60 degrees, that's 300 degrees. And so in this first one, we get u equals 180 degrees. Or in the second one, because one of these has to be the zeros, or u equals 30 degrees or 300 degrees. So final solution here, in order from least to greatest, 30 degrees, 180 degrees, and 300 degrees. Okay, I'm going to take it to Desmos really quickly, and I'm just going to show you what this equation looks like when we graph it, just so that if you have to check your answers, you remember how to do that. So let me go into these first two equations here, and I'm going to use the intercept method where I take 2 cosine squared x on the left side, set that equal to y, and 1 minus cosine x on the right side and set that equal to y. We're going to look for their intersections. And you'll notice that I have my Desmos set here in degrees. I have it in degrees, and I have my x-axis will just go from 0 to 360. And then we'll just look for the intersections of the two lines there, the two curves. So 60 degrees, 180 degrees, and 300 degrees. So verification of that your factoring or our factoring was correct. Okay, back to what we are doing. Let's take a look at the next equation. So it says solve sine squared beta minus sine beta equals 0 in 0 to 2 pi. So this is in radians. So let's take a look at that. Maybe you don't like to factor. It's definitely quadratic. You don't like to factor in terms of trig terms. So we'll just say we're going to let sine beta be replaced with b. And so this would be b squared minus b equals 0. We can factor here, a common factor of b, so we'll factor out the b. And that'll leave us with b minus 1 equals 0. And so we get b equals 0, or b minus 1 equals 0, using the principle of 0 factors. We'll add 1 to the other side. So we get b equals 0, or b equals 1. Now we'll go ahead and just reinsert sine of beta for b, because we were asked to find beta. So sine of beta equals 0, or sine of beta equals 1. All right, so where does that happen? Now remember, sine of beta is your y-coordinate. So when your y-coordinate equals 0, this is y equals 0 right here. So that would be here at 0 radians, and here at pi radians, because see here you're at negative 1, 0. There's your sine of beta and 1, 0. So this one would be beta equals 0 and pi. And when sine of beta, or your y-coordinate equals 1, that happens up here, right here. And this is pi over 2. So beta equals pi over 2. And that would be all your solutions for that. So final answer here, in order from least to greatest, that'd be 0, then pi over 2, and then pi. Again, we're going to check this in Desmos. So I'm going to go back to Desmos. And I have this equation here, y equals sine squared x minus sine x. But this is set in degrees here, so what we're going to do is change it back to radians. And we'll go from 0 to 2 pi. And we'll just do a step of, say, pi over 4. And we'll take a look at, and maybe we'll change our x-axis so it's a little bit less dramatic looking there, or less flat. Okay, so our zeros this time, because we have it set, we're looking for our zeros. There's 0, 0, there's pi over 2, and there's pi. And we'll zoom out just a little bit here. So you can see that it's also at 2 pi, but remember that we only can approach pi. It's not, 2 pi is not in the interval. We just can approach 2 pi. Okay, so there's your solutions for that. Okay, let's take a look at this next one. And you'll notice that I have it called the calculator example, and I have it like that for a reason. So we're going to do 10 sine squared beta minus 12 sine beta minus 7 equals 0 in the interval 0 to 360 degrees. So this isn't going to factor, and I'm just going to show it to you really quickly. If we were to multiply those two values there to use our AC method, they would have to multiply to negative 70 and add to negative 12. And you can sit here and you can think about numbers that would multiply to negative 70 and add to negative 12, but there aren't any that, I mean, there are, but we don't know what they are. And so you would have to use a quadratic formula or complete the square to solve this, and that would just be awful. And then because it's not going to end up values on your unit circle, you'll have to rely on your calculator to find a beta anyway. So I say let's just go into our calculator and graph this. So we're going to use the zero method. Make sure our calculator is in degrees. So we're going to type in our equation, our calculator, y equals, instead of 0 equals 10 sine squared beta minus 12 sine beta minus 7. And we're going to graph that picture here. So I'm going to go to Desmos here, turn that off, turn that on, go back 2 degrees, change my x-axis from 0 to 360 degrees, and I'll make it step by 60 degrees. And I think our y-axis on our picture goes from negative 1 to 1. And so you can see this really funny little graph you got going here. I'll zoom way out. Look at that. It's really wild. Okay, so let me zoom in because we're just looking for our solutions or our zeros between 0 and 360 degrees. And we'll just click on the intersection there. So 205.44 degrees and 334.56 degrees. So we'll go back to our note page, or I'm going to go back to my note page. Your note page is in front of you. And we're going to just draw a little sketch of what that looks like. So about right here, your graph is coming up and then going off the page out of this window. And then it's coming back down. Let me scoot over a little bit here. About right here. And then it's going back out of the page. And so what are those values there? This is 205.44 and 0. So there's one of our solutions. So we're going to say beta equals 205.44 degrees. And then here on this value, or at this 0, we were at 334.56. 0. So our other solution here, or our other 0, was 334.56. So again, we use the zero method, where we just made y 0 equal y, and then our y's in our graph were 0. So we're looking for the corresponding x's. And that's how you would do a problem that you couldn't factor. You would just go ahead and rely on your calculator. Okay? All right. Last one here. Now this one's a little more complex, and tomorrow you'll see some more that look like this. And here's one where you have multiple trig functions in the same equation. But this will factor pretty nicely, so I decided that we could look at it today versus looking at it tomorrow. So we'll keep going with that strategy where I'm going to let cosine x, I'm just going to use a as a replacement for that. And then let's see, tangent x, I'll make b. So we'll just do some substitutions here. So 2, and then cosine x, we're going to do cosine squared x, so a squared, b, which is your tangent x, and then tangent x equals b. And so there's our equation there. Okay, and so we're going to find the zeros, so we'll subtract this b over to this side. So 2a squared b minus b equals 0. And then we'll just factor. Common factor is b, so we'll factor that out. So b equals 2a squared minus 1, factored out. And then we'll use our principle of zero products. Either b equals 0 or 2a squared minus 1 equals 0. And we'll finish this out. So 2a squared equals 1. Divide 2 on both sides. So a squared equals 2. Square root plus minus, that should be 1 over 2. Plus minus square root of 1 over 2. So that's a equals 1 over square plus minus, 1 1 over square root of 2. So let's rationalize that denominator real quick. All right, so that's a equals plus n minus the square root of 2 over 2. Now we'll come back in here and we'll just substitute back in our trig values or our trig functions here. So tangent x equals 0. So that just means that our slope is 0. So that's pretty easy to do on our graph. A 0 slope is this flat line right here where you have sine divided by cosine, 1 tangent sine over cosine, right? So 0 divided by 1 is 0, so that's 0 radians. And then over here on our 0 slope, we also have negative 1, 0. And if we divide sine by cosine, it's also 0. And so that's pi. And so those are our two solutions for tangent x. And then for, I should have done that in red. I'm sorry I didn't. All right, for A, we're going to resubstitute in cosine of x. Let me fix that up, that's terrible. Cosine x equals plus and minus square root of 2 over 2. Plus and minus square root of 2 over 2. Okay, so that's approximately 0.71, so about right there. And so we have that value. And that value at the square root of 2 over 2, and then over here, negative square root of 2 over 2. And that would be that value and that value. And I'm sure you recognize those as pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So let's write our solutions here. Here's what we know. For tangent x, we get x equals 0 and pi. And for cosine x, we get x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So if we write our solutions out in order from least to greatest, that's 0, pi over 4, 3 pi over 4, pi, 5 pi over 4, and 7 pi over 4. And that'll be in our interval from, and that would be in our interval from 0 to 2 pi approaching. Okay, and we'll look at this real quick on the calculator, and then we'll be done with this lesson. So let's take a look at the graphing calculator here. And so what I have here is I'm using the intersect method where I set one side of the equation equal to 0, and I set the other side of the equation equal to 0. What I'm going to do first, though, is change this back to radians, which makes the graph look really wild. And put it back in those values, and then I'll just put pi over 4 since that was a nice place for the answer. So let's scroll out just a little bit, and then we're looking for the intersection. So here's 1 at 0, 0. Here's 1 at pi over 4, 3 pi over 4, pi, 5 pi over 4, and 7 pi over 4, and we don't include 2 pi. And so there you can see in the intersection method that that's true. The other thing you could do is you could just set both of them. You could just say, okay, so y equals, I'm going to copy paste because I don't want to type this again, minus tangent x, and put everything on the same side of the equation like we did when we factored. Let me clean that up right there. And then instead we could just look for the zeros. So I'll turn that off. And then you can see the zeros here at 0, pi over 4, 3 pi over 4, pi, 5 pi over 4, and 7 pi over 4. So whichever method you like better, that's the one that you should use. Okay, and so your assignment today, I forgot what it was, but it is up on Canvas, so you should be able to get that done and submitted before Saturday at midnight. Have a good one.